In 13.7, we're going to be looking at inequalities and equations simultaneously. The inequality makes it so that you cannot do linear combination. You don't have things simultaneously being equal. There's a range of answers, so you must use substitution. Now, I'm not going to normally ask you in this way. I'm going to ask in an application way, but I want to work through the skill first so you see that as we work through the applications. In the first one, I'm asking for x. So since I'm asking for x, I'm going to take the equation. You're always taking the equation, and I'm going to solve that for y. Then I'm going to come over here, and I'm going to take the inequality. So my 2x is coming from up here, minus 3, and in for y, I'm going to put 9 minus x. I will solve that. So that would be my final answer for x, is that x is greater than 3. For y, to start, I'm going to come over here. I'm going to try and change the color here so we don't get too confused. And I'm going to solve for the other one. I'll solve for x so that when I plug it in, I only have y's left. So again, the equation always goes into the inequality. So I start with the 2, that's right here. In place of x, I will put 9 minus y. I'm going to solve it. Making sure I flip the inequality because I divided both sides by a negative. In the next side, a couple things here. A new elementary school is to have 50 faculty members. 50, it can't have 40, it can't have 60. 50 is an exact number, it must have that. Some will be teachers and the rest will be aides. At this school, teachers will earn an average of $20,000 per year and aides an average of $12,000 per year. So to define variables for each, that just means tell me what the variables mean. So x is going to be my number of teachers, y is going to be my number of aides, and then I have to write an expression for the total amount of money paid. Well, I'm going to take $20,000 and multiply that by the number of teachers. That will give me how much I spent on teacher salaries. Then I have to add in 12,000 times the number of aides. That gives me how much money I spent on the aides. The next question says, what, and again, I'm sorry, this is worded poorly. What is the total paid if there are 20 teachers and 30 aides? So I'm going to just plug in 20 and 30. So I have 20,000 times 20 plus 12,000 times 30 gives me 400,000 plus 360,000. So if I have 20 teachers and 30 aides, I will spend $760,000 at the school. Now, suppose that the amount to be spent on salaries must be less than $896,000. Find the minimum number of aides that can be hired. There are 2 restrictions put on you. First of all, you do have to have 50 faculty members, teachers and aides, to open the school. Then, we know we have to pay each teacher $20,000 and each aide $12,000. And that total amount of money has to be less than $896,000. They asked me to find the minimum number of aides. And for me, aides is being represented by the y. So I'm going to take the equation, I'm going to solve it for x, so that I'll only have y's left when I substitute. So I'm going to take 20,000 times 50 minus y plus 12,000. Y is less than $896,000. Now, an option here that I'm going to use is I'm going to divide everything here by 1,000 and everything here by 1,000. You don't have to do that. That's just to help me get smaller numbers. I tend to mess numbers up when they're too large. So all I did was divide 1,000,000 by 1,000, 20,000 by 1,000, 12,000 by 1,000, and 896,000 by 1,000. That just makes the numbers a little smaller, a little easier for me to work with. When I go to here, that gives me negative 8y is less than negative 4. Let me just check that quickly. And so when I divide that, remember that you flipped that you're dividing by a negative, so you need to flip the inequality. So that should give me 13. So remember to answer the question. Find the minimum number of aids that can be hired. The number of aids, which is represented by y, must be greater than 13. All right, well, what's the smallest number that's greater than 13? 14. They could hire more. The more aides you hire, because they cost less, the less your total will be. In the next one, we have a manufacturer can produce 40 television sets per day. He doesn't produce 50 or 30. He definitely produces 40 every day. So I'm going to call X my color, Y black and white. I took this from the book, so I understand this is dated kind of television sets. I know that the number of televisions manufactured is absolutely 40, so that's my equation. Now to get the total, I see that color sets sell for 400 each, and black and white sell for 100 each. If the manufacturer wants to make more than 14,500 a day, find the maximum number of black and white. So I'm going to take 400, multiply that by X. That'll give me the amount of money that I get for selling color. 100 times Y will give me how much money I make for all the black and whites. And when I add them together, that's my total money. I want to make more than 14,500. Now, it asked me to find black and white. Black and white I have represented by Y. So I'm going to solve this for X. I'm going to come down here and plug that in for X. Oops. Now again, we have a common factor. There's several. I'm just going to divide by 100 because that's a really easy factor to divide by, but you can divide. There are better common factors here. And that just is to help me get smaller numbers. You don't have to do this step. then I get negative 3y greater than negative 15, so y is less than 5. But then don't forget to talk about what this means. In order for these restrictions, I make 40 televisions, my earnings is greater than $14,500, the number of black and white must be less than 5. So what is the maximum number I can make? Well, what's the next highest number less than 5? 4 is the maximum number of black and white. Okay, so make sure you answer the question. And the last piece, I'm going to skip that one. Some of you have that. I'm skipping this. That's the same idea. This one's a little different. So I have to take 1,000 units per day total of vitamin A and B. And again, it could be 500, 500, 200, 800. There's a lot of variation. But it says here, the number of units of vitamin A, okay, that's represented by A. So the number of units of vitamin A must be at least is going to mean greater than or equal to 2/3 of B. So this looks a little different because you guys are used to a number A, a number B. So make sure you read what it says and just very literally, what represents this? How do I say each part mathematically? Now I'm only going to work through one of the variables right now, even though it does say both, just for the sake of time in a video. I'm going to solve for A. That'll give my dosage for B. So over here, I'm going to plug in I'm going to add B to both sides. So I have 1,000. Please remember, when I add B, that's like adding 1 to both sides. So 1 plus 2/3 is 1 2/3 or 5/3 B. Then I'm going to multiply both sides by the reciprocal. I'll do that in green, I think. Give that a try. So I'm going to take this side, I'm going to multiply it by 3/5. And I'm going to do the same thing to the other side. This is just doing some algebra with you again. So I'm multiplying both sides by 3/5. When I do that, the 5 and the 1,000 will simplify to be 200. 200 times 3 is 600. And the B's, 3 and the 3 will cancel, the 5 and the 5, so I get B. So the permissible daily doses, I know B has to be less than or equal to 600. So the permissible doses for B would be anywhere from 0, it's the smallest amount you can take, to 600 units of B. Now from this you may be able to figure out the units of A as well. If B is 600, A is going to be 400 to 1,000. If this last part confuses you, you can just do it again for A and you'll see where that came from.